Hello, everyone. I think we can start. So this is Software Mention Academy. Our third webinar is going to be hosted by Josh Goldberg from Codecademy. And the title is Speedy Expo Apps with Persistent Redux State. So yeah, I hope everyone is staying safe in this and during those times. And yeah, we've prepared with Software Mention Academy a little bit of entertainment for you this evening or this morning, depending on in which time zone you are. And thanks to Josh, we'll have this great presentation today. So the topic is really something very relevant, I think, to everyone who does React Native, and it's something that I've encountered many times in different apps. So almost every app that I've been working on requires some sort of persistence layer, and one way to do that is with Redux and redux-persist. So Josh is going to be covering that, and yeah, he's really one of the best people to to talk about this topic because he works on Codecademy, which is one of the biggest deployment on top of Expo as a platform. So yeah, give him a warm welcome and do like a virtual applause for him. And yeah, I think we're ready to get started. So enjoy the talk, and after the talk, we'll have a QA session with Josh. You should be able to ask questions during the chat. I'm not sure if Josh is going to be answering them though, like during the talk. So there is a QA session at the end, but whenever you want to ask a question, there's this plus button in the right bottom corner next to the chat window. So just click that plus and there is a ask a question option. So use that for asking questions, and yeah, enjoy the talk, and yep, give a virtual applause to Josh. Thank you.
Well, thanks everyone for the virtual applause. I appreciate it. It's really exciting to see so many people here. Thank you for coming out virtually. Not all traditions have really survived this remote time, but I do want to continue mine of taking a selfie before the talk that will be posted on Twitter. Don't worry, your face won't be in it. As was stated, we're going to talk today about Speedy Expo apps with persistent Redux states. If you're curious about code samples or a link to these slides, you can go to the GitHub repository, Joshua K. Goldberg /Speedy Persistent States. You can find a quick little Expo sample app there that showcases a lot of the utilities and tools and patterns used in here. A quick little introduction about me first. I'm Josh. Hello. I'm from New York, the city, in New York, the state in the United States. I moved to Seattle for a bit where I became a cat dad. I'm now in Brooklyn, which is a part of the New York City and New York State in the States. I'm still a cat dad. That is a stock photo. That is not me. I maintain some libraries that work around TypeScript and static analysis, which you should have either stopped using by now or have only used once and then forgotten about. Feel free to talk to me later about those. My goal today for all of you is that we want to describe some patterns that we can use to effectively and performantly hydrate our data so that the user doesn't have to wait too long to use their applications. As a sub-goal, I also want to evangelize open source software a little bit. That's going to involve a few things. There we go. Yes, the slides are now on the stream and they are linked to with annotations in the repository. The agenda today is going to be, I'm going to talk to you about the situation. We're good. The situation with the apps that we might be encountering as developers of Expo or Redux Native or generally web apps. I'm going to go over a few typical approaches that I've seen common to a lot of sites and applications. We're going to talk about how we can adapt those approaches to our different kinds of data needs, even within a page. And then some pro tips about how you can do those persistent strategies more effectively and safely. Finally, we'll talk about how open source's magic had made all this possible. Cool. Let's begin. So, although I work at Codecademy, as was mentioned, and I personally have worked on the Codecademy Go app, which is our mobile app, one of the biggest Expo apps, in the world. The sponsors said that we probably shouldn't be corporate shills, and we're going to talk instead about a different app because this app wasn't even set up by me. I'm kind of a sham here, a phony. So we're just going to talk about a generic app that I actually have written, which is the linked companion app. This is just a very simple app that wants to show you some data. It's got a home screen. On that home screen, we have the user's profile photo, maybe some achievements counts, maybe some basic data. Really, it's three pieces of data we want to load here. We have the user profile data, the achievements count, and the recommended content. Now, these 3 pieces of data are pretty representative of really common forms of data that you often see in the wild. We have data that rarely changes. I'm going to call that cold data. We have data that sometimes changes. I'm going to call that warm data. And then the frequent hot change data, which happens multiple times a day, perhaps even multiple times an hour or minutes, that's hot stuff. Going in order, the rarely changed stuff might be something like a user profile, because those things are very rarely changed, and users kind of normally send up updates for that manually on their own. It's very rare that a user's profile photo might get changed for them. Achievements are similar in that they're not super common. You won't have it multiple times a minute, but they don't really happen extremely frequently, not many times a minute, for example. And then the hot data, you might see this as happening very frequently, very often. The user might ask for it frequently, but definitely it updates pretty quickly, so we don't want to get that thing out of date. Cool. Now, let's talk about the common ways that we tend to load this stuff before we go into fancy strategies. I call this one naive laziness, or a common naive approach, in that we first, pardon me, wrong slides, in that we first render the loading text, then we send fetch requests for cold, warm, and hot data. Once those finish, we store them all in the store, and then finally, once that's done, we render the page. And your Redux side of this might look a little bit like this, where we have a hydrate data function which dispatches an action after loading. Now, if you haven't played with Redux or Thunks before and you were kind of hoping this talk would explain it, you're like kind of in luck. I'm not going to go into how the full Redux, Redux Thunk, or Redux Saga, etc. systems work, but you'll get enough context clues that I hope you can go on by. Feel free to ask in the Q&A later if you'd like some clarifications. In this particular code snippet, the real takeaway is that there were 2 parts to the logic for this hydrate data method. I've grayed away, made darker the boilerplate code that you don't need to pay too much attention to. The first part of the logic is that we await a promise.all of 3 data loading methods: fetch cold data, fetch warm data, fetch hot data. The results of those per normal promise.all usage is that they're stored in an array, and that array is given back to you once all 3 of those have completed. Once those complete, we then dispatch an action, let's say hydrated data in this case, that contains all of them. I'm not going to show that action in the slides, as I'd like to not have to go through the full Redux pipeline, but we can assume that what it does is take in some data and then store that data in the application state. This is a fairly typical approach you might see in a lot of Redux-based applications or other Flux implementations. The React side of it is a little more complicated, but itself still has 2 main, maybe 3 main pieces of logic. Similar to before, if you're not familiar with React hooks, you're kind of in luck. Feel free to QA after. I'm going to kind of gloss over the basics of it, but you can still get the basics and the kind of ways that we're using them in this presentation through context clues. This naive component has first a bit of logic to dispatch the hydrate data function that we saw in the previous slide. If you've never seen use effect before, this is a function that takes in a function and an optional array. And when that array is empty, it just calls the function once on mount, which makes it pretty equivalent to the existing React class componented mount method. After that hydrate data has been called on mount the first time, we use a redux selector to retrieve any data that we've loaded in the state. If the data hasn't yet loaded, we render this React component. If the data has loaded, we then render the rest of the app, cold, warm, and hot data. Again, I'm not going to show that selector here, but you can imagine that it, from your Redux state, selects some of the data that we're loading. Ta-da, we're loaded. Now, this is a nice and easy approach to implement. Your app probably has more complicated shenanigans going on, but the straightforward basics are straightforward. A nice user experience here is also that we tend to load everything at once. The con is we take a long time to load stuff. I mean, the entire app waits for all 3 requests. which can be slow. Maybe the hot data takes a while to compute. Suppose it's a list of user activity, and to query all the user databases, all the tables, it takes a while. And if one request fails, maybe you're on a mobile device and you're on a subway, and 1 in 5 requests tend to fail, then it never finishes. The entire app has to wait because one of your calls has failed or might be taking a while. So this approach can be improved. Let's go on to selective laziness, which is the approach you see on a lot of sites, for example, Facebook.com, where each part of the page that depends on a particular area of data has its own loading mechanism. Each of them first renders with loading text. Once they render, after some amount of time, they might come in. The way that they come in, the way that they display data, is that we've sent granular fetch requests for all 3 pieces of data, and then each of them dispatches a hydration event when it's done. The code for that might look a little something like this, where we still have this one hydrate data thunk that's sent out. We still do a promise.all with 3 fetches in it. But after each fetch, instead of after the entire promise.all, we then dispatch a hydration event, an action, saying which particular piece of data has been loaded. The selector and whether to load or rendering logic for this is moved outside of this root component. In this case, I'm going to call it selective. So we still, on componented mounts, the use effect with empty array, we still call to hydrate data. But in each of the components, we then handle lazy loading. Pardon me. So in the cold component, we have our logic. It's taken on the burden of knowing when to render. So if we use this, again, not displayed here, select cold selector, and the data doesn't exist, we render a placeholder. In the case of the cold component, that placeholder might be, say, a circle with 3 dots in it. Once the data is loaded, we then show the regular thing with the data. I'll note that one of the nice things about the new Redux hooks is the components still get mounted and hooked up to the Redux state. So this component will re-render itself once this select cold results, once the cold data has been loaded. Similarly, warm data, we have a little bit cleaner logic here. Maybe we'll use a just an OR operation to render the ... instead of a number. We have a new piece of syntax here, actually, this question mark. It's called nullish coalescing. And if you're not yet familiar with it, I personally think this might be the most exciting part of the talk for you. The existing pipe OR operator in JavaScript considers things like the empty string and 0 to be falsy. But in this case, if the count is 0, we still want it to be considered. So nullish coalescing is nice here because it only considers null and undefined to be falsy. That allows us to show a warm data value of 0. You don't need to understand anything about nullish coalescing for this talk, but it's a very exciting new operator. It's in latest versions of JavaScript. It's been implemented in TypeScript and Babel. Good stuff. Moving on, hot data, similar to the profile data. It doesn't matter what kind of data hydration policy. I know it is going to change our lives. It doesn't matter what kind of policies you have for the data, whether it's hot, warm, cold, the logic's fairly similar, which is kind of a nice separation of concerns here. We don't care what form the data is. We just care that it has been loaded. On the surface, selective laziness seems like a really good step forward from naive laziness, which I think it is. The page's loading animation makes it feel like the apps are coming in a lot faster. You already get the skeleton of it. You know what's happening before you would have previously. In hindsight, we could have probably modified the naive approach to use the dots everywhere, but it was simpler the way it was. Selective laziness does have another key behavior improvement, that if a single request goes down, if you're on the subway and your cold data doesn't load, the rest of the page can still work. We render each page component as soon as it's ready, so one request failing doesn't prevent the others. On the other hand, a con, this is a little bit more to write. We had to add in individual loading behaviors for each part of the app, which is a little bit of a pain as a developer. So if you're just working at a hackathon, maybe you have a quick deadline, you don't really need to use this pattern if loading behaviors aren't really a main concern of the app. And the really key thing here is that I'm going to harp on this a lot. The data behaviors matter differently to different people. what you need for your app is not necessarily going to be what everyone else needs for their app. So it's important that as we go through these different patterns, you think internally, what would I need in which situation? Not, oh, this is the best one for every situation. Cool. So those are two common strategies. Blocking the whole page, keeping it simple, versus keeping it a little complex and then selectively loading things in. I want to talk a little bit about how we can go back to the basics and try to optimize for the data behaviors that we saw at the beginning, hot, warm, cold. What kind of optimizations can we make for better loading patterns? In other words, what kind of data are we actually looking at here, and how are we going to deal with it? Two of them in particular probably seem like a little bit of a Groundhog Day situation. Fun fact, that is an animated GIF, and PowerPoint Online is not rendering it. Thank you, Microsoft. Two pieces of data, the cold and warm, don't tend to update fairly frequently. Our cold profile photo, who updates that? I said it once and it's the same way for 12 years. The warm achievements count might update, but it's not a very frequent thing. If someone's visiting our app over and over again, if they're really into our content, they don't need to experience a loading screen every single time to get this data. Maybe most of the time, maybe some of the time, but certainly not every time. It would be really nice if there would be some kind of way for us to persist the data locally between sessions. Now, fortunately, this app idea already exists. Someone actually wrote this. There is a great synchronized storage plugin, React Native Community/async storage, which you can install on NPM or Yarn or whatever your favorite package manager is. It used to be part of React Native, the core packages that were sent out, and now it's managed by the very fun React Native community. Self-described, it is an asynchronous, unencrypted, persistent key value storage solution for your React Native application. I'll note that it is very similar, in at least theory, to the local storage APIs you've used in the browser before. So if you're not familiar with this one, that's okay. It is a local storage for your phone. So let's modify our data strategy here. First, we restore cached cold and warm data from device storage in case we previously stored it. We then send out requests for cold, warm, and hot data. And then once the cold and warm ones complete, in addition to actioning, to dispatching their data to be stored in the Redux state, we also store them locally. This means that when the app first loads, we can immediately get very quickly the data that was stored in our local storage, our async storage. Now this code is a little bit to look at, but I want to go through it quickly. I'm aware there's a lot to read through, but it's actually pretty sweet. First, for each of cold and warm, we look at what's in async storage, we get item, and then we dispatch the hydrated data with that cold data. So the rest of the app doesn't care how we got the data. It doesn't care that it came from storage, it came from the fetcher or whatever. It just receives the dispatched event, which is very in line with the Redux principles of an action just gets fired. It doesn't matter too much where it came from. Once that cold stuff has been put into our storage, if it existed already, then we do the normal fetch cold data.then. And here, in addition to dispatching a hydrate data, we also set item in our storage. Key is cold, value is the data. And you can see from the full loop here, the full function, that there are two pieces of logic. First, we hydrate from the existing data, and then we hydrate from the new fresh data, which means if the data already existed on the phone, it still gets updated. Now, the logic for our root application, our root selective component is pretty much the same. I don't see any difference here. Still loads nicely. So this is great. I mean, our data gets immediately available and it remains persistent. That solves basically all of the performance loading concerns from the previous strategy. The downside here, and this is very important for developers, is that that's a lot more code to write and maintain. I had to use 2 Bill Murray GIFs to explain the strategy here. That's more than the normal amount. We don't want to have to repeat that copy and paste stuff every time. It's probably not worth it for our application. And you can see in the wild, a lot of applications re-render data very frequently that they could have just kept stored locally because it's often not really worth the load. mean, people have better things to be doing to add to the application than optimizing loading times on every single part of the components. So we want to keep our Redux state in sync with our device storage, but we don't always do that. Well, if only there existed some kind of automated system to synchronize our state with device storage. That was spoiled at the beginning of the talk. That is redux-persist. It's a joy. Honestly, it's a fantastic package to work with. I'd highly recommend it. We use it on our Codecademy Go app. We're investigating it in our website. I've been looking at it for personal projects. It's great. It's a library for Redux, and it does exactly what we want. It synchronizes the Redux states to the device storage. It's compatible with synchronous forms of storage, such as the aforementioned browser local storage. And very important for this talk, it's very compatible with asynchronous storage, such as the React Native async storage package. Like with every good JavaScript package, it's available on your favorite package manager, npm, yarn, etc. Because we have this idea now of synchronized storage where everything just magically works within our existing storage patterns, we don't have to complicate our logic very much at all. We can have the same logic from roughly the first and second strategies, the naive and selective. The logic changed is now first that we synchronize the device storage in Redux, and then we send those same fetch requests that we were before and hydrate the data once they come back. All that fancy logic that we have to implement about then set item and get item before that, it's gone. It's magic. It's disappeared. Now there is another little bit of copy paste here. This is boilerplate code. I copy and pasted it from the redux-persist README. You can copy and paste it as well. The gist is that it wraps your normal Redux state data and the creation logic for it. That's fine. There's a little bit more copy and paste boilerplate that you need to do if you're using it with, for example, React, in that you have to have this persist gate wrapper around your roots, which is a little bit of an extra cost because there needs to be a loading screen shown when you are loading in your asynchronous data. You don't have to provide a component. It can just be null. But in this case, I thought, why not show the big loading one? But in practice, this is actually very fast. Anyway, beyond this copy paste, the logic for our actual hydrate data function is quite simple again. It's again back to the selective form, which I'm personally very pleased with. It's this nice simplicity. It's just a regular thunk. There's no async storage. It's a lot easier to test now, let me tell you. So the pro of this is that we get similar performance gains to the general async storage strategy, but there's a lot less handwritten code. This is what we use in a lot of our apps. There are a couple cons. The small one is that there is a very minor startup penalty to read your previous data, which does get bigger as you have more data by a little bit. It does get accidentally, it becomes accidentally possible to display some old data, which is not great. That is quite a big drawback you can imagine in this day and age where everything needs to be safe and secure. There's nothing in the app in our code that stopped the hot data from immediately rendering from storage. There's nothing that prevented it from being in the persisted state, which might be a good thing. You might consider that to be an accidental win where we didn't have to write out the code for it. But it could also be a bad thing. It's possible that there are pieces of data that you don't want persisted. It could be stuff that's too sensitive to be reused. It could be stuff that just doesn't make sense to be reused. If you have live data that's supposed to be sent in from a very, very quick feed, maybe your TikTok, and it's getting displayed a week later when the person opens the app, in a lot of cases, that just doesn't make sense for your users. And again, you have to really understand your data. In this case, we're learning that persistent data is not always persistent. It might not last forever, and your app needs to know how to handle that. So there are a few configurations that you can use within redux-persist. It has a few options for filter functions, things that massage your data, maybe remove, maybe change them when you read or write from storage. There are some community solutions that let you make allow lists or deny lists for different parts of your app. Those work well, but there is a downside to understanding the shape of your data in your configuration layer. It makes it so that changes to your configuration layer need to be reflected in your data, and your data changes need to be reflected in your configuration. Those are not particularly exciting to do. There is a lot of copy paste already, so I'm not going to show those in this talk. But we can introduce a strategy about recency. If we want to really only show the hot data for a very brief amount of time, we can store timestamps in our code to explain within the state whether something should still be shown. Or an alternate phrasing of that is, if we store a timestamp alongside our data, we can choose not to render the data based off that timestamp. In this case, it might just be that hot component, the live feed or some such. So our strategy becomes still not as simple as originally, but relatively straightforward. First, we synchronize our device storage in Redux, as before. Then we send granular fetch requests for cold, warm, and hot data. And alongside the hot data, once that thing finishes, we then store a timestamp. Maybe it's sent from a server, maybe it's, I don't know, just computed on the client. And then lastly, in our render logic, we only render the hot data if it's within a timestamp. So our hydrate data thunk looks pretty similar to before. The cold data and the warm data are just the same. They don't care about timestamps. And if we're computing the timestamp, let's say on the client, we have a little bit extra code for this. In addition to storing the data under, let's say, hot.hot or hot.data, we also use arbitrarily date.now, which generates a Unix timestamp alongside it. Now we know in our Redux state, this is when this was hydrated. In our React code, it's a little bit more complicated, unfortunately. Depending on your data, you'll need to understand when is it okay to hydrate this. In this particular area, let's say that there's an arbitrary threshold of 1 second or 1,000 milliseconds times 60 seconds a minute times 5 for a total of 5 minutes. In this, we will render the today placeholder if either of the two following cases have been hit. We'll render the today placeholder if there is no hot data, and we'll also render it if the difference between the hot data timestamp and the current timestamp is greater than that arbitrary threshold. Now, you might be picking up on a kind of dangerous thing, a relatively unsafe practice we're doing of calling a constantly changing API, in this case, date.now in our render function. Please do recall that if the Redux data changes, this component will re-render. So once the hot data has loaded in, this thing will re-render. Otherwise, if the hot data never loads in, if that hot request fails, or, well, it's a second time, who knows, then we'll just never render again. Or maybe we'll re-render again because the root component changed. But that's okay, because these components, well, they're not going to suddenly start rendering data and a later render. It's only going to render today items if the hot timestamp has gone closer to the present. So it becomes a little convoluted, this logic that we're trying to figure out. But on the bright side, we no longer have to deal with the data persistence woos of the hot data. We only retain data persistence unless we don't want to. Now, that is a little bit extra code to write and maintain. We still have the ability to code things improperly. We might mess it up. But for the most part, this strategy, at least when applied properly, can help us not show the data that we don't want to. So at this point, we've achieved what is probably the maximum reasonable performance that we would expect to be able to get out of our Redux application without using some kind of background tasks. Data is persistent, and it's available as soon as we can reasonably get it on load. We load it immediately from storage if it's there. And then if the data is not out of date, we'll render it. Furthermore, the data gets immediately requested on component mount. So even if the data is out of date and we can't render it, we'll get a new data as soon as we can. The end architecture requires a little bit of fine tuning, and we could honestly fall back into displaying old data if we mess it up in a later update. But overall, it's pretty snazzy. I personally am rather satisfied with these options, and I don't have the strength of will, or to be honest, remaining talk time to display more of them. And I can't think of particularly complex ones that I would even want to show in public. So that's the meat of it. Now that we've gone over some strategies, I do want to give you some pro tips about this stuff because there are data strategies you may or may not need in different apps, and it's sometimes tricky to figure out what stuff you want. Again, each of these strategies has some pros and some cons, and you'll need to understand them before choosing any for whatever application it is you're writing. So pro tip, please always know your options. This is a rough table. It might not be accurate for all of the times and all of them, but it could also help you visualize where each strategy stands as applied to that very specific dummy application that we've been looking at so far. There's some general rules that you can see kind of scrutinizing at the data. Safety tends to, on average, decrease as you get more fancy, and it never gets good again after you start synchronizing your storage because you might mess up, you might display something you didn't mean to. Cleanliness also tends to decrease. Resiliency and speed, on the other hand, go up over time, which is nice. As you put more effort into your app, one would hope that you get some nice speed gains. It's kind of a pretty table. I like the colors. Now, you might be tempted to add some kind of like cutesy generalized scoring system here where maybe it's number of check marks minus number of X's. Maybe you would or wouldn't care about the little yellow squigglies. You might compute it per row. You might compute it per whatever adjective or noun. But that's very dangerous because that assumes an equal weighting of each of these columns. You might have to assume for that strategy that cleanliness is just as important to you as resiliency. And honestly, in most applications, it really isn't. You have to decide per project for this stuff. You can't just choose your own strategy like a football team and expect it to always, win the cup. A project where, let's say, ease of development and visual safety are way more important than, say, initial or repeat performance, some sort of government contract or private security shindig. Those would probably choose maybe naive or selective laziness. They, probably wouldn't care so much for exact sub-second loading times as much as safety and resiliency. So please, know your data. I also want to give the tip that it's often better to be safe than sorry. The joke is not relevant, but to this presentation, I just think it's funny. You need to know when not to persist. It's often easier to mess up than it is to just not do the dangerous strategy in the first place. But if it's not something that you can guarantee safety from, if you don't think you have, for example, the resources, the development resources to make sure your app doesn't get broken over time, maybe don't choose the dangerous strategies. If you do want to persist, understand your data behaviors. We are able to apply some nice optimizations that in practice will achieve a much better user experience before, because we understood we had hot data, warm data, cold data, and we understood when to use different strategies for each of them. Make sure that you also have that understanding when you're developing your app. Let's say that you have a login system and accounts, and your app might get used in schools. Well, your login system might not synchronize with the application login logout system. Let's say you're on Android or iOS and people just pass the phone to each other. In that case, you're going to need to be able to clear your cache data if the user within your application logs out, but the overall root OS application does not log out. It's only a matter of time before someone on a shared device will pass it to someone who they don't really know and don't really trust, and then maybe your login data has been compromised in that way. Maybe that's an attack vector on security's perspective. It's important that you understand what type of things your application might be used for, and as a general rule of thumb, if there is a cache bust event, such as a logout, just clear your data. I mean, what's the worst that happens? It's slow for the next startup. It's probably fine. Who knows? Who am I to tell you what to do with your application? Lastly, I want to evangelize open source a little bit because this topic's very important to me, and it's made this entire thing absurdly possible relative to how it would have been. These are all kind of plug-and-play strategies we can take from the open source world and shove them into our app. And that's possible because all sorts of stuff in the open source world is open source. Let's look at some examples. Here we have that React and Redux are open source, and they have these nice integrations with each other. We have a use selector hook from the React Redux library, which adopted to the new React hook system very quickly. Now, these are technically separate projects, but they're very much both developed in the open, particularly Redux, and they have people who work together on both of them. They talk, the maintainers hang out once in a while. So there's a whole ecosystem for each of them that has a huge overlap because they're commonly used together. Same too with React Redux and redux-persist. Now, React Redux isn't the same project as Redux, but it's open source and they work together a lot and they have shared goals. Redux-persist doesn't really talk to React much, but it does talk to Redux. And it's able to be so successful and useful as it is because Redux is in the open and they're able to collaborate so quickly. Some kind of privatized approach wouldn't work for them. Following that, on the flip side of the stack, React itself is open and extensible. And there's this huge investment that, granted, a very similar source company came from, React Native, that is able to work with it and is now very much a community-funded and community-participated project with some corporate sponsorship. Beyond that, we have RNC, or React Native Community Async Storage, which is very much a community-sponsored and maintained project, which is built on top of React Native. And Expo, our favorite React Native bundler packager open source thing, is, despite being very much a company, an open source project. And these things all work together amazingly, all these huge, seemingly disparate areas of investment because they're open source and they fit together nicely because of that. You get the drift. I could go on. So I want to end with a couple of very visually put together slides. One person working on something is not as good as an entire community. Even excluding the communal benefits, a library opening itself up on GitHub gives itself a lot of invaluable advantages for transparency, accountability, approachability, and contributions. These libraries, React, Redux, etc., they can be inspected, scrutinized, actually understood, when reasonable, by the consumers of those libraries, us, the developers. We, as the contributors, the consumers, we can actually debug through the libraries and their issues and descriptions and prior work to understand how they work and how our usage of them or they are going wrong. There's an old expression, 2 minds are better than 1. Imagine the entire world's working with you. So I do want to note the open source ecosystem isn't perfect. There are a lot of unanswered questions, unsolved problems around, let's say, maintainer burnout, sustainable funding, community stewardship, the inevitable politicizing of freely available goods such as software. But open source is powerful enough that we can create these standardized plug and play approaches like the ones you saw in this presentation today. We do this by linking together open source tools with little pieces of our own application logic. And suddenly we have these fully fledged applications that can work with minimal effort on our end. Honestly, it's magic. So the next time you're architecting your own application, your own feature, try not to think of it in terms of what you can build on your own, what kind of stuff that you can write. Think of it in terms of what are the needs that can be satisfied by freely available things, and what is the minimum amount of work that you can do to get things working on your own? What can you do to contribute back, to use existing stuff rather than starting from scratch? Doing so will help, of course, minimize work on your end, but it also makes the open source community a little more powerful just on its own. Fun stuff. So to recap, we first talked about a common situation. We have app with data. App with data needs to load. We talked about some typical approaches to loading that data. We talked about how we can adapt that data to the needs of the app and how we can adapt our approaches to the data itself. We talked about some pro tips for how to persist that data, some of the strategies that we use to adapt. And then we talked about the entire thing being possible because of open source software. I'm going to open it up to Q&A now. After one note, I do want to thank Software Imagine for hosting this thing and letting me talk. I really appreciate it. And I would also like to thank you as the audience for listening to me this whole 39 minutes and 22 seconds. So thank you. I think that's all I got, and we're ready for QA. Ooh, I guess I'll go here. Is there a limit to how much data we can store? Also, would it ever fail to set data besides when there isn't enough space? It's a good question. I would defer to the docs on this one for both of those. For the limit to data, I would imagine that this is set by React Native as a factor of how much data is on your app and how much the application OS will allow. I would suggest adhering to the Redux strategy of limiting what's in your state to be pure serializable objects with IDs as references rather than data copies. If you have a full list of objects that have GUIDs or UUIDs, don't copy those into separate places, just refer to them by those IDs or GUIDs. But that really is a factor of what your device is capable of. As to whether it would ever fail to set data besides when there isn't enough space, you could have a permission denied error in theory, or maybe there's a bug in a library. Code has been known to have bugs. But again, I would defer to the documentation here. For reference, Codecademy Go uses persistent data for the entire app. We do the cache busting strategy on logout, and otherwise virtually everything, including our data telemetry, important user events, is stored in React Redux via redux-persist. And we have never had any problems that we know of, I should say, due to data storage limits or not enough space or generic crashes thereof. I'll go to the next one, I guess. Can I speak on redux-persist migrations, which we also use in our app? For beginners, what is a migration? Are the best practices for organization or migrations? Redux-persist is amazing, but if you mess up a migration on a version update, your app could try to launch with corrupted data continuously. How do you handle that sort of nightmare situation, which could break an app out of the field? That's a very advanced and good question. A migration is when your Redux data changes shape, which is going to happen at some point over the time of a well-developed application. Maybe you used to store things in one way, and then you decided to store things in another way. Now, there are a few strategies you can take for when the shape of your Redux state changes. You could ignore that and just let the data be gone. You could write a migration, which in redux-persist terms is a function that takes in your old states and poops out your new states, which it can be implemented in more complex of a way than that, but that's the general idea. The nice thing is you can go from old state to new state seamlessly. Redux-persist will magically handle it for you. The downside is if there's a bug, if you mess up, if something else messes up, the application's data could be corrupted. Extreme amounts of testing is very nice. I would highly recommend you take these things extremely seriously. Change data shape incredibly rarely, preferably never, as close to never as possible. Assuming that your application does eventually need to do such a thing, I would strongly suggest having a way for the app to handle these kinds of failures. If there's a hook in an API you can attach to, like an on error or the redux-persist hook, which I will refer to the docs for the usefulness and existence of, make sure that it can handle a failed migration. Tell the user, hey, I'm sorry, all the local data was lost. Please reinstall the app. Frowny face, give us feedback. Which brings up the point of try not to let a user be your source of truth for anything. Users are incredibly fickle and painfully bad at keeping things. Devices get trashed, stolen, lost all the time. You know, an Android comes out and an Android update comes out and they just like reinstall everything. Those are the pieces of advice I'll have. I'm sure that there are more in the docs about how to do these kinds of things, but I've personally only shepherded 2 migrations out in the field in my career, and both were heavily tested first so that we wouldn't have to deal with any sort of pain because we were very, very scared of them. Cool. What is the advantage that Redux compares to a React context with useReducer? Ooh, great question. So the new React hooks update came with a lot of good stuff. It came with some very basic replacements for the existing class components cycle. Instead of this.state and this.setState, we had useStates. Instead of component and mount, component will update, etc., we have useEffect. It also came with a few very carefully crafted built-ins to replace some common patterns. One of them is useReducer, which kind of replaces the functionality of Redux. It lets you implement your own dispatch and action and then update the state as a result logic. I would highly recommend that, at least trying it out. And then for small apps using it, it's great. I mean, it's built in, it's less dependency hell to go through. However, Redux itself has a huge community and a lot of really nice tools built in. A few examples of things, so to speak, that are built in for Redux are the dev tools, which enable time travel debugging. You can go back and forth to different state shapes with your app. things like redux-persist that I know of have not yet been implemented for React. And if they haven't been popular enough for me to notice them. I don't know how big of a signal that is, but certainly redux-persist is only possible with Redux itself. I would also say that Redux asynchronicity is hard, and general reducer asynchronicity is hard. How do you dispatch an async, whatever it's going to be, thunk, saga, whatever your usage calls it? So built-in, common middleware for Redux, such as Redux thunks, is really nice. The Redux docs recommend Redux thunks as a really easy way to set up a function that takes in a dispatch and then gets states. So yeah, I would not recommend against the new built-in user reducer on small scale, but for larger projects, it is often, though admittedly not always, worth it to use a community library such as Redux. Personally, I also really like MobX and Immer as other alternatives to just using React. So if you haven't heard of those, 10 out of 10 would check them out. I have not heard of Rematch for Redux is a next question. That would be why I haven't mentioned it. What is I don't know this React Native Context API versus Redux. As I mentioned earlier, this entire talk is a sham. I am a paper developer. I am a fraud. So I don't know anything you mentioned, and I'm sorry, I can't answer your question meaningfully, Michael. The next question is there a package to install that helps reduce or helps use Redux or improve its performance? There is a Redux toolkit package that they highly recommend in their docs. I forget if it's strongly recommend or highly recommend. They recently introduced very nice verbiage to explain how powerful the recommendations are meant to be. It doesn't, that I know of, significantly change performance patterns, but it makes it a lot easier to use Redux. It removes a lot of the boilerplate, the like copy and paste. You always have to do this stuff. So I'd highly recommend, not just for people who are new to Redux, but for everyone, try out the Redux toolkit. Even if you think you don't need it, or if your application literally doesn't need it, it'll make it easier for you, or give you experience in something that makes it easier to explain Redux to junior devs or people who are new to it. As for performance, we at Codecademy are heavily use reselect, I want to say, which is a library. I'm not an expert on this stuff, let's just say that, which is a library that allows you to combine selectors together and has a lot of nice caching behavior. I'd recommend looking into that one, reselect. But we have been slowly over the years more and more convinced that we really don't need to use it for the majority of our scenarios. React and Redux by themselves with React Redux, the library, are pretty fast. So I would suggest the common performance recommendation of don't care until you care. I mean, until measurement shows that you have a problem, most of the time you really don't need to do anything with performance. In fact, there are a lot of activities or actions people have taken that I've seen that actually reduce overall perceived performance in the effort to improve it. Like if you install this huge package in order to make your runtime behavior faster, but then your actual startup times are slow and your runtime behavior is not perceivably faster, then like you've lost ground. One step forward, two steps back. Cool. Have I tried Recoil for state management? No, but I'm really excited about it. Recoil is a new library that is a very experimental, very explicitly not ready for production use. Don't go build an application for production with it right now. Its API will change. Its docs are very clear about that, but it's being developed by people, I want to say, at Facebook. And it's kind of intended to be a next step, a next alternative to traditional things like Redux and MobX, which are themselves alternatives or improvements upon, depending who you ask, Redux states, or pardon me, React states. Recoil looks really cool. It has a lot of great things that I like some of the reducer / flux style logic that you see in things such as Redux, some of the observability, niceness, computed states that you see from things like MobX. RX is cool too. I imagine there's inspiration there. I would recommend checking it out if you have time. It's like a fun little thing to play around with. And in maybe some single digit number of years, it'll be production ready and maybe even the next big thing. Let's hope. Currently, the community is leaning very heavily towards Redux, and I understand why. I, too, lean heavily towards Redux these days for that reason. How does Redux compare to MobX State Tree? I have not actually used MobX State Tree. I cannot reasonably answer that question. I've used vanilla MobX with React before and loved it on an application that was very, very dynamic. It was a thing called Sway from Microsoft, if you want to look it up. We were rewriting the view layer. It's these documents that are auto-generated from abstract trees that contain the contents and styles. So for something like that, MobX worked incredibly well. It worked well with Inversify, which is a library for JavaScript that lets you inject dependencies. That's a whole other talk right there I'd love to give. But no, I can't answer to MobX State Tree versus Redux specifically. I would say, though, that if you haven't considered them, that's fine. All these things work very well. If you do have time, that is yet another thing that I'd recommend tinkering around with, MobX and MobX State Tree. It's from the same person who makes Gimmer now. Are there any performance comparisons one needs to be aware of between using Redux or MobX in terms of large applications? That is not a comparison that I would feel comfortable making. That is apples to oranges. They are both very good for optimizing performance, and they are both very fast for performance by default. So I'll say again what I said earlier. Don't worry about performance. These things are all good enough for very frequent use. Even things like MobX that aren't very popular or common these days relative to Redux. So really, performance is fine until it's not, so long as you have a performance-friendly architecture to begin with. The types of things that I would worry more about for performance are like your data loading strategies, the number of elements, DOM elements you have on the page at once, not should we use React or MobX. Can I suggest some open source projects that use Redux for state management? Ooh. I can't think of any off the top of my head. I know they exist. Probably the Redux dev tools. But no, I would suggest going to the Redux docs, and they'll have links to applications there. So the Redux docs would be a good example. Cool. Any other questions? Well, look, these were really fun to answer. I always love an excuse to talk. I am a tech person. Feel free to reach out to me on Twitter. My contact info is in the slides. You can look me up. SWM has been tweeting about this thing, so you can always tweet at me, DM, email, whatever, if you're curious about things. And yeah, file issues on the companion app if you find any issues with it. Thanks, everyone.